And then we'll get started because I haven't grabbed pizza yet, so we can just, and then everybody wants to chat or whatever. I don't know. But this is exciting. We're going to be able to do it.
So what type of stuff do you do for Vivint? Like,
mostly
what
break
are
things to production. That's my general role.
Okay.
I'm,
Like, what are they?
right,
'Cause it's solar, so it's not like a.
Yep.
It's not
So Vivint Solar's a third company, sold off, got
wrong,
acquired
different
by,
building.
Yeah, this is Vivint Smart Home.
That's where the okay. So you do have like a lot of
Vivint
consumer
Solar
facing stuff.
rebranded.
Yeah, we got some well they got acquired by another company and
That's
their
right.
Yeah.
name, can't remember the name right now, but
My bad. I thought I was in the
no,
Vivint Solar building.
a lot of people do that. No, this is so we're the smart home security side, so it's the home security system, automated locks and thermostats and cameras and all that fun stuff.
Yeah, that's crazy. It's probably sounds intense from like a you always have to be up. I mean, like everybody does this, but you guys really do.
I like it. But I'll say my interview here, the person who became my boss asked, what do I do for fun? I was like, well, I've been working at a startup, so I've been super busy. I used to skydive and work on ambulance and things like that. And he's like,
Yeah.
well, what do you do for the adrenaline rush now? And I said, I push code straight to production. So, and then he hired me. So, and then after a while, put me in charge of the ops team. So I feel like it was implicit approval for that approach. So I've just been doing that ever since.
It's crazy. So it sounds like a rush.
It is.
Terrifying.
Yeah. I like it.
Cool.
Do you create a webhook for production pushes that like just starts playing Living on a Prayer?
No, we actually push quite often now.
So it would just be restarting all the time?
Yes. Well, it's like early on, I've actually got the hardware upstairs, so it doesn't work right now. Someone made something that had one of those red lights that spins, and it would play a cha-ching noise every time someone installed one of our systems.
Mm-hmm.
And then, if we're ramping up, that was okay, but now it's not okay. So it's been shelved for many years.
Have you guys seen the dashboard someone made that it follows the system logs or like any sort of logging, and it plays like different tonal music, and so it'll kind of just be calm as normal stuff is happening, but if you get errors, all of a sudden it's like
I haven't seen that, but I like that.
it's on GitHub. Yeah, I thought it was actually kind of cool because they're like, we just keep it up on a TV like this, and if you've got a production issue, pretty quick. It's not exactly like distracting annoying, but it's obvious uh-oh. We just heard 20 drum beats in 10 seconds and it's not stopping. There's a production issue.
I like it.
It's very clever.
Okay, shall I get us started? Well, I guess we've already kind of been started, but we're chatting and we're doing the thing. That's what we're here for. Okay, so everybody, welcome. We're going to have a night with Crockford. So basically, we're just going to watch some publicly available past talks of his from a decade ago that I think are still just as, if not more relevant today than they've ever been, which is on just real fundamentals of JavaScript. And some of the things that he presents were standardized in a different way. So feel free at any time to pause. I literally had to watch several sections of this multiple times in order to understand them. So feel free to call pause at any point. We'll discuss it. I want to give a quick shout out to Jeff and Vivint for hosting us.
And Travis is also from Vivint here.
Oh yeah, Travis. And thank you for the pizzas. Travis is, oh there he is, yep, he's right there. Thanks for the pizza, everything. To everybody that's joining in online, if at any point you find this to be useful or entertaining, consider a thumbs up, like, sub, follow, all those things. But also consider doing it on the original video, which I'm going to post that into the chat right now, so that anybody that wants to watch the real deal can watch the real deal there. Oh, and I'm going to take away that little mabob. So let me just post this real quick. Oh, it's already in the Discord. I need to just post it in the chat. I'll post it in the chat. If I can find the chat, where did the chat go? And then we'll go ahead and get started, and hopefully the audio will be okay. And we'll just roll with it. So, here we are for a night with Crockford. Huzzah!
But you can work around that, and there's a lot of good stuff here.
Just get from the start.
Okay, so tonight, Act 3, Function the Ultimate. We're going to be talking about functions tonight. Functions are the very best part of JavaScript. It's where most of the power is, it's where the beauty is. But like everything else in JavaScript, they're not quite right, but you can work around that, and there's a lot of good stuff here. So tonight, unlike the previous 2 nights, I'm going to be showing you quite a lot of code. Because we're talking about functions, you need to see how they work. I personally tend to fall asleep in presentations that put a lot of code on the screen. It's just kind of not a good time. So I have a lot of examples, and I tried to make them all fit on one screen in big type. So they're all going to be simple, but they should be interesting and useful. So let's begin. Function. Function is the key idea in JavaScript. It's what makes it so good and so powerful. In other languages, you've got lots of things. You've got methods, classes, constructors, modules, and more. In JavaScript, there's just function, and function does all of those things and more. That's not a deficiency. That's actually a wonderful thing, having one thing that can do a lot and do it brilliantly at scale. That's what functions do in this language. So here's what a function is. A function is the word function. It optionally has a name, which can be used to allow it to call itself. It can have a set of parameters, which are wrapped in parens, containing 0 or more names, which are separated by commas. And it can have a body, which is wrapped in curly braces, containing 0 or more statements. A function expression like that produces an instance of a function object. And function objects in this language are first class, which means that they can be passed as an argument to another function. They may be returned as a return value from a function. They can be assigned to a variable, and they can be stored in an object or an array. So anything you can do with any other kind of value in this language, you can do with a function. So a function expression is like an object literal in that it produces a value, except in this case, it produces something that inherits from function.prototype. It may seem kind of strange that a function can inherit methods from something else, but it can. So in this language, functions have methods. That may sound odd, but we've got that. And I'll show you some examples of that. We have a var statement, which allows us to declare and initialize variables within a function. Because JavaScript is not a strongly typed language, you don't specify types in the var statement. You just give a name for the variable. Any variable can contain any value that's expressible in the language. A variable that's declared anywhere within a function is visible everywhere within the function. We don't respect block scope. So the way var statements work is the var statement gets split into 2 pieces. The declaration part gets hoisted to the top of the function and is initialized with undefined, and then back at the place where the original var statement was, it gets turned into an assignment statement so that the var gets removed. So here we have an example. I've got my var equals 0 and my other var. What that does is, at the top of the function, it defines my var and my other var and sets them both to undefined. Then at the point in the function where the original var statement was, we have an assignment statement. The separation and the hoisting operation changes the way you might think of the scoping of variable names. We also have a function statement. And unfortunately, the function statement looks exactly like a function expression. The only difference is that the name, instead of being optional, is now mandatory. But in all other respects, it looks exactly the same. And it is confusing to have both.
I want to pause real quick. In the chat, somebody asked, is let better to use now? Is there a difference? There is a difference. Whether or not it's better to use is a matter of subjectivity. You can still use both of them. Anybody want to tackle that?
Howie's talking about how the vars get hoisted up to the top of the function scope. Let and const kind of encapsulate that into a block instead of the whole function level. So if you're wanting to do, I don't use var anymore, but I typically use const most of the time. Some people just like using let.
I think it also helps with like expressing what you're trying to do with a variable. Like, is it going to be reassignable, or is it going to be like hard setting? The const, it's set, it's done, and your intention is not to reassign it.
I also think it's a good indication that you might be using some newer JavaScript in your code and not what Crockford is mentioning because of the ES6, 7, and all those. Like, it's a good indication if you start seeing let, you're not using like a very old library. So.
Well, I don't. Lots of old libraries used let, and then they just used Babel to transpile it to var. So, I mean, a lot of the code on the web today doesn't use let when it actually hits a browser. If it's on Node, then yeah.
Yeah, I guess I do mostly Node for that kind of stuff.
Yeah, but now that they've fixed most of the bugs with let, there's only one bug that I'm familiar with let that remains, and there's no way to fix it. I mostly use let because it is nice to have the block scoping as opposed to the function scoping in a lot of cases. But I think that in a way it's kind of a code smell too. Like var will reveal code smells because if your function is growing long and has too many concerns and too many things are going on and you start to get confused because you've got too many vars up at the top and where they're used is far apart from where they're declared, I think that's a good indicator that you should break your stuff down a little bit and make it so your functions can fit in a single 50-line block or so rather than being so long that you can't tell what's going on in your function anymore. And the one thing that's broken about let is if you try to use let in a switch statement, you have to add extra blocks. So normally in a switch statement, you don't need a block with each case, but if you use let, then you have to have a block with each case. Otherwise, you have a quantum let because it will be both declared and undeclared in every case, and it will not be scoped to the switch block. So it's kind of a weird thing. Any other comments, questions? All right. Carrying on. Let me put that on.
So why do we have both? Well, the function statement was the older thing, and the function expression, which is really the more useful form, was added to the language later. So what the function statement does is it expands into a var statement, which creates a variable and assigns a function value to it. And that expansion, because it's a var statement, it's actually a var statement, splits into two things, except unlike the ordinary var statement that we saw earlier, both pieces of it are hoisted to the top of the function. So things are not necessarily declared in the order that you think they are. So it's confusing having both function expressions and function statements. So how do you know which is which when you're looking at it? And the rule is if the first token of a statement is function, then it's a function statement. Otherwise, it's a function expression. Generally, function expressions are easier to reason about. For example, you can't put a function statement inside of an if statement because of the hoisting stuff. You might want to have a different function being defined if you take the else branch or the then branch, but hoisting doesn't look at the branching, and it happens before we know the result of the if. So the language definition says that you can't do that. It turns out every browser lets you do that anyway, but because the language definition doesn't tell you what it's supposed to do, they all do something different. So that's one of those edge cases that you want to stay away from. So we have, in this language, function scope. In most other languages that have C syntax, we have block scope. And because of the way vars get hoisted, block scope doesn't work in this language. In JavaScript, blocks do not have scope. Scope means that if in another language, such as Java, if you declare a variable inside of a block, inside of curly braces, it's visible only inside of the curly braces and not outside. But that doesn't happen in JavaScript because of hoisting. The variable declaration gets pulled out of the if statement and moved to the top of the function. So the variables will be visible everywhere within the function. Only functions in this language have scope. If you declare a variable in a function, that variable is not visible outside of the function, but it's still visible everywhere within the function. So if you're coming from other languages, this can be confusing. For example, a function like this will work in most other languages and will fail in JavaScript without an error. What you'll find is that it will run forever. And that's because the programmer thinks he's created two I variables, but in fact there's only one I variable. And so the inner loop is constantly resetting the I value so that the outer loop will never finish. So that's something to be aware of. In JavaScript, you can't be depending on block scope. So because of hoisting, because of the way that variable statements and function statements work, I recommend that you declare all variables at the top of the function and declare all functions before you call them. In other languages, the prevailing style is declare variables near the site of their first use. And in languages which have block scope, that's good advice. But I don't recommend it in this language.
It's also important to note that if you use JSHint, ESLint, any sort of editor, Prettier, all of those will complain if you were to do something that's dangerous. So you don't really have to keep that in your head because you'll get a little squiggly. Well, hopefully you're not using Notepad because then your commits have mixes of tabs and spaces, extra line endings, and non-printing characters, and \R. Just how I like them. Right. Any other questions, comments, thoughts?
Variety's the spice of life.
We have a return statement. A return statement allows a function to return early and also indicates what value the function should be returning. And there are two forms of it. There's one that takes an expression and one that does not. If there's no expression, then the value that gets returned is undefined. It turns out every function in JavaScript returns a value, and if you don't explicitly say what the value is, it will return the undefined value, unless it was called as a constructor, in which case it'll return the new object that you're constructing. One other note, you cannot put a line break between the word return and the expression. Semicolon insertion will go in and turn it into a statement that returns undefined, which is tragically awful. There are two pseudo parameters that every function.
So that's actually a really good argument for why, rather than trying to write cute JavaScript, write JavaScript according to the spec, put semicolons. Again, your editor, if you have semicolons enabled, it'll be very clear from your editor and the code formatter whenever a problem like that crops up, because all of a sudden everything will shift to the left to be aligned with the return. And you know if something's aligned with the return, then it got screwed up. If you don't use semicolons, then and you don't have any tooling. I would never recommend programming JavaScript or any language without the tooling that's native to that language. But yeah, you get a lot more benefit if you follow the spec of the language and and use tools that follow it too, so you can see when there's errors like that.
When you say the spec of the language, do you mean turning your code editor on to include semicolons? Are there other things that are within that spec like that you'd want to do?
I think if you use prettier and you have a linter, anytime that your code is ambiguous or weird, you're going to notice, because you're either going to get a squiggly because it'll say, wait, this scope is used in 2 places, or this is declared in such a way that maybe it's not in the scope that you thought it was. But the semicolon, I think, is the biggest thing that is a language requirement that people often ignore. Because the language requires semicolons. It just so happens that the parser will insert a semicolon where it's required if you didn't put it there yourself. So you're basically leaving it up to chance. And there's only a handful of cases where it matters. There's 4 or 5 cases where it matters. But would you rather just have your editor automatically insert semicolons whenever you save? Or would you rather always remember those 4 or 5 things and always be checking every line of code that you're obeying the rules?
But if you're using prettier, it does that anyways.
Right, so that's what I'm saying. You just put on prettier, use a linter, and then you don't have to worry about these problems.
That's why I disabled prettier.
Right, okay. Moving on.
There's one contrarian in the room.
Function can receive. One is called arguments, and the other has the unfortunate name of this. So let's look at arguments first. When a function is invoked, in addition to the parameters that it declares, it also gets a special parameter called arguments. And it contains all of the arguments that were actually specified in the invocation. It's an array-like object, but it is not an array, which is unfortunate, and I'll show you some examples of why that's unfortunate. It's array-like in that it has a length property, so you can ask arguments how many parameters were actually, or how many arguments were actually passed to this function, which might be different than the number of parameters that you specified. It also has very weird interaction with parameters. If you change one of the elements of the arguments array, you may change one of the parameters that it's associated with. And if you do something really scary like do splicing on the arguments array, you may scramble and reassign all of your parameters. So generally, you don't want to mess with the arguments array. While the language doesn't require you to treat it as a read-only structure, I highly recommend that you treat it as a read-only structure. Okay.
So I just wanted to comment on that. This is the only place in JavaScript where pointers are used. Every other place in JavaScript, you either have values or references. The arguments object is the only place where and that's why it works this way, is because it's a pointer. So if you replace something in it, it actually replaces the memory structure of what it's assigned to, because the arguments are, it's not an array. The arguments list, the arguments group. The references are actually pointers. Or, well, technically they're some hodgepodge thing that doesn't have a name, but it's, if you were in C and you assigned 2 to B, and then all of a sudden A changed, that would be because the memory location of A and B are the same, and you can't get that behavior in JavaScript anywhere except for here.
Okay, so let's look at an example. I want to have a function in which I can pass it some number of numbers, and it will then add them all and return the result. So the way I do that is first I look at arguments.length to find out how many numbers I'm going to be adding, and then I will have a loop which will go through each of those members of the arguments pseudo array and figure out the total, and then when it's done, it returns the total. This is how you would write that in ES3 or in the 3rd edition of the ECMAScript standard. This gets a little bit nicer in the 5th edition. In the 5th edition, arguments is more array-like than before. It's more array-like in that it actually inherits now from array.prototype. And array.prototype now contains some interesting functions like reduce. So I can call arguments.reduce and pass it a function that does adding. And the result of that will be to add up all the properties, all the members of that array and return it. So it's, I think, a more elegant way of expressing the same program. Then we have the this parameter. I'm discovering that I don't like the name this because it makes it really difficult to talk about it. My first sentence, the this parameter, already you're in trouble. I mean, it's just hard to talk about it. And in doing code reviews, I said, "Oh, I see your problem. This is wrong." Is it? So, well, you might be right. So what is this? The this parameter contains a reference to the object of invocation. This allows a method to know what object it is concerned with. It allows a single instance of a function object to service many functions. You can take a single function object and store it in lots of different objects, or put it in lots of prototypes and allow it to be inherited by even more objects. And there's just one instance of the function in the system, but all of those objects think that they have that method, and they will do the right thing with it because they use this to figure out what object they should actually be manipulating. So this is the key to prototypal inheritance. Prototypal inheritance works in this language because of this. We have the parens suffix operator, which is used for invoking or calling or executing a function. It surrounds 0 or more comma-separated expressions, which will become the arguments of the function. And those arguments will be bound to the parameters of the function. If a function is called with too many arguments, the extra arguments are ignored. You don't get an error for that. They're just ignored, but they'll still go into the arguments array. So if you want to find out about them, they're still accessible to you. If a function is called with too few arguments, that's not an error either. It will fill in undefined for any things that you did not include. And there's no implicit type checking at all. So if the types of the parameters are important to you, you need to check them yourself within your function. There are 4 ways to call a function. There's the function form, the method form, the constructor form, and the apply form. And they differ in what they do with this. So in the method form, we have an object, and then we say dot function name or subscript, some method name, and then pass some arguments. That will call the function, and it will associate this with whatever that object was. And that will allow the function then to manipulate this. Then there's the function form, in which we simply take a function value and call it immediately. In this case, there's no object to associate this to. So in ES3, this was set to the global object, which was just awful. In ES5 strict, we improved that a little bit. We now bind this to undefined, which is less awful. But one problem with this form is sometimes if you have an inner function inside of an outer method, and that method wants the inner function to have access to this, it doesn't have access to it because it has its own this, which is different than the outer this. So in order to make this visible to the inner function, the outer function can declare a variable, perhaps called that, assign this to it, and then the inner function will have access to that. We have a constructor form, which looks like the function form, except we have the new prefix. So now when the function is called, this is bound to a new object that inherits from the function's prototype member. Then if the function does not explicitly return a value, then that new object will be returned. This is used very much in the pseudo-classical style, which we'll look at a little bit later. Then finally, there's the apply form, in which we use either the function's apply method or its call method. What they have in common is they both allow us to specify what this is. So the value that this should have will be the first parameter. The difference between them is apply takes an array of arguments, and call takes 0 or more individual parameters, which will become the arguments. I show how to define call in terms of apply, and also show a little bit of the ugliness that's caused by the fact that arguments is not a real array. So what I want to do is, to implement call, I want to take all of the parameters that were passed, except for the first one, and I do that by using the splice method, except arguments doesn't have a splice method in ES3, so instead I have to go out and find it, and I know that I can find it at array.prototype. So I go array.prototype.slice.apply, and then I can take that piece of arguments. Really awful. Again, we fixed that in ES5 a little bit. So to summarize, this is a bonus parameter, and its value depends on the calling form. If it's called as a function, it's bound to either the global object in ES3 or to undefined in ES5 strict. If it's called as a method, it's bound to the object containing the method. If it's called as a constructor, it's bound to the new object being constructed. And if it's called in the apply form, then we explicitly pass in an argument that determines what this is going to be. We call these things functions, but they don't behave exactly like mathematical functions. In a mathematical function, you would expect that every time you use a function with a particular set of inputs, you should get exactly the same outputs. And there's some programming languages in which people are trying to match that ideal. And there's some attractiveness in doing that because the behavior of programs is more predictable, it's easier to reason about them, and they're also a lot harder to write. Because it turns out programs, in order to be interesting, are interacting with the world, and the world is always different. And so the functions are always going to be dealing with different things, and so they'll tend to want to keep state and to manipulate that state and to mutate things. And so functions will tend to have side effects. So in JavaScript, you can program in the pure functional sense, and that you can assume, okay, I'm never going to assign to a variable, and I'm never going to change any object once it's created. And the language will let you do that, but you're going to find it's really hard. So we tend to change things a lot because it's just a easier style of programming. So where did functions come from? Well, originally there was something called the subroutine. The subroutine began life back in the assembly language era, where you'd want to be able to define your own opcodes, and you could take a bunch of instructions that you use frequently and create a pseudo-op and call it. And so functions, or subroutines, were born and introduced the idea of call and return, where we call the thing, and when it's finished, it comes back, and we resume from where we were. And that idea has been in virtually every language since then. In different languages, they've been called subs, procedures, procs, funcs, functions, lambdas, but it's all the same idea of taking some specification of computation, packaging it so that it can be reused conveniently. So the first motivation for subroutines was code reuse. The first generations of computers had really small memories. And so in order to get programs to fit, you'd want to take pieces of the program that were recurring and factor them out so that they were only there once and then call them. That was the only way you could hope to get it to fit. It turned out that was such a good idea that was then used in the design of programs, that treating a program as a single monolithic list of instructions was too difficult to reason about. So if we divide and conquer that program into smaller components, then we can think about those components more easily, and a subroutine or a function was a natural form for doing that. The next step was using them to do modular things. For example, to create libraries of routines that could be loaded with any program so that you could have stuff that would be reused from one program to another. and that led to a sense of expressiveness where in thinking about how to design an application, you would first think of what set of subroutines would make it really easy to write this application. Essentially design a programming language expressed as subroutine calls, which are ideal for implementing this application, and then write those subroutines. The next step up was higher order functions, in which we're going to do things with functions which couldn't be done otherwise. And that's when some of the power of the language really starts to work for you. One of the cases where that occurs is in recursion. Recursion is when a function calls itself or is defined in terms of itself. Now, at first, this didn't make sense to some programs. For example, if you were working in Fortran, Fortran couldn't do this. It was not possible for a function to call itself in Fortran. So a lot of very good programmers looked at the idea of recursion and reasoned that, well, I've never used it, and I don't understand the need for it, therefore it could not be very important. But it turns out it's actually really important, and when you learn to think recursively, you become a much stronger programmer. So one of the classic algorithms for a recursive solution is the quicksort, which was invented basically because ALGOL was invented, and expressing this in a recursive programming language turned out to be really easy. So there are basically two steps in quicksort. The first is you divide an array into two groups, all the big values and all the small values. And one way you could do that is you could have two pointers that are going through the array, and one starts on the small end and one starts on the big end, and when either find something that's in the wrong group, they swap them, and then continue scanning in until they meet. And when they meet, you're done. So then you go to step two, whereas you take each of those groups and call quicksort on those groups, and you're done. That's the whole sort, and it's really fast. There are more optimizations you can do to it to make it even faster, but just doing what I was describing in the average case is n log n, which is really good for a sort, and you don't hardly do anything. It's just really, really simple. So once you can learn to think recursively, a lot of really interesting things fall out. Here's another kind of recursion. You might recognize these from the JSON language. We've got the syntax diagrams for values and arrays. And you might notice that there's a dependence issue going on here where a value can be an array, but an array can contain a value. And a naive programmer might struggle in thinking, well, how do I organize my functions in order to parse something like this? I've got this circular dependency, and that's really hard. But it turns out if you have recursion working for you, there's a trivial solution to this. So here I have two functions. Each exactly implements one of the syntax diagrams. I've got the value, which when it sees a square bracket, will call the array method or array function and return whatever it returns. And then I've got my array function, and for each of the things that it finds, it calls value to find out what it is. So here I've got mutual recursion going on, and it all works out. And so you don't have to think about how to manage the transition from one to another. Just the ordinary function plumbing does all of that work for you. You don't even have to think about it. Lisp had this stuff going on in 1958. ALGOL had it in 60, but it took a while to get into the mainstream languages, partly because people couldn't think about how to implement it efficiently. At that time, the way subroutine calls worked, on most machines, you had self-modifying instructions. So when you called a function, it would destroy whatever is in the first word of the function and replace it with a jump back to the place that it was called from. And you couldn't do that recursively because once you clobbered that address, there's no getting back. So you needed some other place to keep the return values. And eventually that turned out to be a stack. All modern CPUs now have support for that, usually in the form of auto-incrementing or auto-decrementing pointer instructions. These assembly language notions eventually found their way into programming languages. So these things, come straight out of assembly language, but found their way into C and into Java and everything else. I don't like them. They look way too primitive and fish brain to me, if you know what I mean. I think we can do better than that. One of the other key ideas, again, which was alien to people who'd never used it, was closure. For people who were working in languages in which closure was not an option, it was like, I've been programming for years without it. I don't understand why I'd ever want it. But it turns out JavaScript's got it, and it's really, really good, and that's where we're going to be spending most of our time tonight. So it's sometimes called lexical scoping, sometimes called static scoping. It has to do with how variable names are resolved in nested functions. So the context of an inner function includes the scope of the outer functions. So all of the variables that are in the outer function are available to the inner function. And this continues even after the parent function has returned. That sounds kind of weird. So I've got a lot of examples to show you what this means. So I'll start with a simple one. I've got a function called digit name. And digit name will take a number as an argument and will return the name of that number in English. And it will take advantage of an array of strings that's stored in names. And as you can see, it's a really simple function. Unfortunately, the way I've defined it here, names is a global variable. And the problem with that is if there's anything else in the environment that is also a global variable that has that name, they're going to interfere with each other and will probably cause this to fail. And that's something you cannot test for because it's impossible to test with everything that might be loaded on a page, for example. It might be that a third-party ad gets loaded one day that happens to have a global variable called name, and now your page died. So that's intolerable. So we want to, as much as possible, reduce our dependence on global variables. So one way we could do that is to rewrite this program so that names is now a local variable of the digit name function. And that works. So it's a local variable. We have function scope. Names is not visible on the outside. So even if an evil ad comes in and has a names variable, it will not interfere with this one. So that's good. This is a much more reliable version of the function. Unfortunately, every time we call the function, we're going to allocate a new array and stuff 10 things into it, which is going to take some time. And we don't want to do that. That's a terrible waste. In this case, it's a fairly trivial thing, but we might have a more complicated function with more complicated initialization, so we want to be able to factor that out. And Clojure provides a really nice way to do that. So now I have a function, and it has a private names variable, and it returns a function. And the function it returns is assigned to digit name. So the important thing is, notice at the bottom, we're invoking the function now. We're invoking the function immediately. So what I'm storing in digit name is not the whole function. It is the function that it returns. Okay? This is really important. And in order to give the reader a clue that there's something interesting going on here, because assigning a function looks almost the same as assigning a function that's immediately invoked, I wrapped it in parens. So the whole thing is wrapped in the golden parens. And that's a clue to the reader. It's not required by the language, but I think it is required by humans. It gives us a clue that there's something really interesting going on here. So we assign the return value of the outer function to digit name. The outer function has now returned. Digit name now contains a function, which is the green function, and that green function still has access to names, even though names is a private variable of a function that's already returned. That's closure. That one function closes over the variables of another function. And this turns out to be one of the most important features in JavaScript. This is the thing that it got amazingly right. And this is the thing that makes JavaScript one of the world's brilliant programming languages.
It doesn't reallocate that every time you call it.
Okay, so the way that he wrote this was really, he gave a really bad example because he's trying to fit it on a slide. Give me just a second here. I'm just going to grab his function and then
There's a
I'll just put this in a gist if I can. Oh no, it's going to make me be sign in. I'll put it on a list then. There we go. So, what
Did a
he's,
terrible job.
what?
But did a terrible job of converting that.
Yeah, well, it is kind of at an angle. Usually it does pretty good. Okay, so what he's basically showing here is a module pattern. Let me see if I can just.
What? Yeah, 1, 2, 5 are missing.
So that this, yeah, I would hope that you would actually never write code quite like this. He's just coming up with something really quick and trying to fit it on a slide. And so if you fit things on a slide, then you need to remove new lines. And if you remove new lines, then sometimes things end up being nonsensical. Let's see. And now, what was he doing? Did he name function?
Name that function, I think, should be a return, shouldn't it? Or did you swap?
Digit name equals function up top, and then digit name equals
Is
function.
this the older one now?
Oh,
Uh,
this
It
is,
went back a little, yeah.
there we go. Yeah, let's do that one. So he switched slides right as I was doing this. Okay, so let's say it's return like this. Okay, sorry. Anyway, the whole point that he's bringing up here is that you can have a function that has access to other data. So essentially, he's just creating a module. So let me break this down again. I'll just break this here. And then something like that. So here's names. And then he's creating a function digit name that has access to the name. So it's just returning this function. And then when you call, well, he's creating a function
That gets immediately invoked.
that, yes, that is immediately invoked. So if we were to do this in a not so stupid way, then we would do it like this: function create digit namer. And then you do var digit name equals create digit namer. And so what that does is it scopes the names to,
Just the creation of it.
yeah, just the function itself. So the names won't leak into other scopes. And this function has access to them, which is what the digit name function has. So if you were to call digit name 1, then it would, what's it called when you use this? It's called no, it's not cardinalizing. Whatever.
Called what?
There's a name for when you take from the numerical form to the word form and the internationalizing it.
No, I actually don't.
Localization?
Yeah, but not localization is for any text. I thought there was a name because there's actually a JavaScript global. It's called INTL that will do this for you now. This particular thing it will do for you, and it'll put the right th or nth, ninth, fourth, that kind of thing.
was, even though, yes, he was trying to keep it on a slide, he was also trying to show that you could still call the exact same function without changing the name of it, and like do it in this better way so that you're not reinitializing the names every time. So like he was keeping the invoking function the same, even though technically it was functioning different under the hood. Does that
So
make sense?
in the next slide, yeah. So the next slide is kind of a memoization technique. So the memory won't be allocated in the same way. I mean, I don't think this. So if you consider the computer, whoops, I gotta bring the volume back up here. So the computer is going to read in the JavaScript, right? So all of that stuff is in memory, whether you're using it or not. It has to read in the JavaScript. Now, if you never call a function, it can release it from memory. But the kind of idea that he's suggesting on the next slide, there are maybe situations where it makes sense if it's an expensive operation where it needs to do some sort of computation or calculation. I don't think that you typically run into that type of problem in JavaScript. But what he's doing here is he creates the function with its name. He doesn't initialize the stuff yet. So we don't actually have a names array yet, like it says lazy. And then when you call it the first time, it replaces the reference to itself with the optimized version. But I think in later videos, he critiques some of the things that he shows in the earlier videos to kind of say, hey, I know I did it this way, but don't do it that way. He doesn't call out this specifically, but I think this is one of those kinds of things where the case that you have for this in the old days would be when you were wanting to put a lot of stuff in a single file in the browser. You might want to have multiple modules that are in different namespaces, but you want to put them in the same file. That's where you use these types of techniques. You wouldn't use them in the age of HTTP2 where you can just have a bunch of files and it doesn't matter because the web server will just send the files that the browser needs at the time that the browser requests, the kind of the first dependency in the chain. So this type of stuff, both via bundlers and via the way that HTTP2 works natively are no longer necessary hacks or workarounds, but yeah, I don't think you're going to run into a case to use this kind of thing today. I think a lot of the value in watching these videos is he explains all 6 ways you can do a thing. And then, later on he kind of says, well, just do this, just do this, just do this, just do this. Don't try to do it all 6 ways. But then when you go and look at code and you think, what the crap is going on here? You at least have an idea of, okay, what's happening.
I mean, this is a good reminder for me. Like, I've gone through a lot of Crockford stuff, but it was when I was first starting out 15, 20 years ago. Like, he was popular when I was like just learning this stuff. And so it's like seeing this, I'm like, oh yeah, that's why I do it that way. Like, I kind of forgot why I did it that way, but yeah.
Isn't there a good bits one that he does? That's the one I saw first.
Yeah.
Well, so that one is a few years earlier. So JavaScript, the good parts, is
Yeah,
a few
the
years
good
earlier
parts.
before this. And then there's the better parts. So I like this one.
And then what would the third one be called? The gooder parts?
Yeah, I think so. I think that's it.
I think I went through the good part stuff, and then I haven't like followed up with him as much. But I'm like, a lot of this stuff is similar. So I was more specifically talking about where it says alert, digit, whatever. He's keeping that the same in each slide as far as I can tell. So
Yeah.
he's trying to show you that you could reorganize this function in different ways and have it function, like work better or more efficient.
Yes.
So that's why I thought he was doing some of the stuff was more so like you don't have to change how you end up calling the function, but you can improve how it works long term.
So
Yes.
Is yes or no? I know this is kind of a deep dive or rabbit hole, but is it, I mean, he's talking about memory. Is it possible to do a memory leak by having a closure like this that you're not aware of?
Well, yeah, of course.
Okay.
Because closure is nothing more than an object. You just have an object that
Yeah,
has
it's capturing
a
references.
non-enumerable. Yeah, it just has a non-enumerable reference to this. So it encapsulates it. You don't have a way to get to it from the outside,
Yeah, there's no way to manage it.
but it's just an object. Functions are objects. Objects are objects. Closures are objects. If you were to look at the way that this is, if you were to look at the C++ code for Node and write a Node plugin, then you would see exactly how closures are implemented.
Yeah, this is the closest you could get to private variables back in the
Yeah.
day.
Well, it's not the closest you can get. This literally is private variables.
Yeah. Well, I mean, like, other languages have, you
Yeah.
define something as private, but JavaScript didn't have that. But if you wanted that functionality, this is how you do it.
Yeah.
Or like I remember everybody wrapping it in immediately invoked functions.
Well,
'cause
that-
they just didn't want anything to pollute the global namespace.
Yeah, the reason for that is because browsers implemented script tags all in the same namespace. They didn't put each script in its own namespace, and they didn't have any way to declare how to namespace something from a script. And so you'd use the pattern that's represented here, the immediately invoked function. You'd use this pattern so that you would capture some innocuous sounding variable like I or names or ID into a namespace that was separate from the other namespaces. Now, the one danger that you don't have to worry about as a Node developer, a lot of these dangers you don't have to worry about Node developers in terms of scope, because Node puts the scope to the file level.
Oh, that would suck if every file was just concatenated.
Well, that's how a lot of the runtimes were before Node. So, for example, if you were to use Rhino, Rhino is just like PHP. You just include one file, include another file, and all scope is the same throughout all the files. So, in the Windows scripting host. So, there have been many, many, many JavaScript interpreters, but Node kind of used the language to its advantages rather than ignoring its advantages. So, one of the reasons JavaScript is so hated, most implementations of JavaScript don't actually follow. Most implementations of JavaScript have no way to do set timeline.
Wow.
So most implementations of JavaScript don't implement an event loop, which seems insane because that's the whole point of JavaScript. But most people just hated it, and it was never implemented correctly until Node. That was the first. As far as I'm aware, Node was the first implementation of JavaScript that was correct, and that's because they used V8 rather than implementing it from scratch.
So everything was basically awaited, like right away? Like there was no...
No, it wasn't awaited because await is asynchronous. Await is not synchronous. This is one of the common
But I
misconceptions.
mean, so like those other scripting languages or those other
They were
engines.
blocking. They were
so,
blocking.
So everyone, if this had to make a database call, you had to wait for it to come back.
Yes,
Right. So there was no choice as to...
correct. There were no callbacks. There was no promises.
I mean, the event loop was created to get around that, wasn't it? Like, to kind of get some functionality of await, but without.
Well, no, await is on the event loop. All of the features of JavaScript that exist today have always existed from the very beginning. There's some syntax sugar changes, but everything that you can do in JavaScript today, you could do pretty much with the second release of it. In the very first release, there were things that were missing, but from the second release onwards, there's nothing in JavaScript today that you can't already, there's nothing new in JavaScript. It is purely syntax sugar.
I think what he's saying is because of the event loop, you now have a wait, right? Is it async await?
But the event loop was always there. It's just that people who are implementing JavaScript literally didn't implement it.
Well, event loop was more specific to JavaScript. I mean, it's more common
Yes.
nowadays, but back in the olden days, pretty much the only language that implemented it was JavaScript.
The only language that implemented it natively.
Yes.
The only language in
And
which
the reason
things
it
like closures
implemented
would
it
work.
natively was to kind of do async await type stuff that would otherwise be blocking in a browser window.
Yeah, because if you want the user to be able to click,
Yes.
and you want something to be able to happen, you
Yeah.
have to have you can't pause until they click, because you don't know which button they're going to click. They might click this button, they might click that button, and so you have to pause the world, or not pause the world. You have to not pause the world and let them click either button, and then respond to the button that they click.
Yeah.
Yeah.
I don't know if that helped, Will. Sorry.
What?
Huh?
No, I understand.
I was trying to be helpful. I don't know if
No,
I helped.
I totally get it, man.
There was a question.
Well, Will
Brilliant
asked a
programming.
question, and I was trying to help, and then we got off on a tangent.
That's good. Any other questions? All right.
Languages. There's another pattern going around called lazy function definition. I show you this as a warning. Don't do this. The idea here is that in this form, I unconditionally initialize the function before we're going to start calling it. But what if the initialization is really expensive, so we don't want to do it unless we know the function is going to end up getting called at least once? So this lazy pattern attempts to do that. So what it does is it assigns to digit name a function, and the first time when that function is called, it will then store another function into the same variable. So it'll replace itself, it'll modify itself. And the idea here is that that allows us to avoid having to initialize the thing if we don't need to do it. But it comes at a cost, and the cost is confusion. That digit name is no longer first class, in that if I were to pass it to a function and let that function call it, or if I were to assign it to an object and let someone call it as a method, every time it gets called from that point on, it will do the initialization and stuff a new function into digit name. So instead of making it faster, we've actually made it slower. It's slower than the slow case that we started off with. Now, the counter argument is, okay, well, you got to be really careful to not do that. So one of the rules that we'll put in the documentation is that this can only be called from the global variable. You can't use the function value as a function value except to call it immediately. And that it's worth it because we're saving the initialization cost. It turns out that analysis is wrong. All we're saving is the cost of an if per iteration. Let me show you why that's the case. So here we're going back to the closure form, except I put an if statement in it, so that if names hasn't been initialized yet, we'll initialize it now, and then we'll do what we always do. So the cost of this compared to the previous one was one if statement per invocation, which is in the noise. It's not even measurable.
So with that, I'd also argue you probably don't even need to worry about this type of thing, because the JIT compilers, if you were using JavaScript in a scripting environment, then this would probably make a difference, maybe. But if you were doing this in any of the environments that you're likely to be doing it in, Node, Dino, iPhone, Android, they all have JIT optimization, and most likely what's going to happen is that if it can tell that something isn't modified, meaning that every time you run the function it's doing the same assignment, and that there's no mutation, there's a good chance that it's just going to essentially hoist it, save that memory location in a different place, and then give you the optimized version.
So branch prediction, basically, right?
I don't think that it's branch prediction, it's just analysis. Because, for example, if you were to use VS Code could tell that this is never modified, right? Or not VS Code, I meant TSC. If you were to use TSC, the TypeScript checker, it's going to be able to tell you that this is never modified. It's going to know that, right? You can look at it and you can see, okay, are there any places where this reference is ever used? Yes. Okay, what operation is done? It's a read operation. Okay, well, if I know that the only place it's ever used is a read operation, then I can, when I interpret the script, at the time that I'm interpreting it, I mean, so even before JIT happens, I mean, just by interpreting this, you can tell that it's read-only. So a lot of the stuff, you know, when it comes to var, let, const, blah, 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 none of it really matters except for tooling, because the optimizer is going to do the most optimal thing that it can do regardless of what you say.
What did you mean by if you're using it in the scripting environment? Because I think of that in the Node.js sense, and then you listed Node.js on the other side of that.
Yeah, so by scripting, I mean actually scripting. So for example, Bash is a scripting language. Duct Tape JS is a
That's what I use.
scripting host. Windows scripting host is a scripting host.
Yeah, it allows you
Rhino
to
is a scripting
embed
host.
JavaScript into C programs.
Okay.
Yeah. So by scripting, I mean that you're literally interpreting byte by byte. You're reading in, and based on what you read in, you choose what to execute. That's not how any of our modern environments work. They read in the entire script, they optimize it to a minimal degree, and then they begin to run it. And then as they run it, they'll optimize it to a further degree. So a JIT, and V8 compiles down to assembly. So V8 is machine code. It's not even like Java, where Java is bytecode. When you run JavaScript through V8, you're not getting bytecode, you're getting machine code. You're getting the most optimized that an interpreted language could ever possibly. Of course they'll make improvements to it somehow, but you're already at the limit.
You're getting the best optimized for what we can do at this point in time.
Yeah.
Yeah.
Yeah, so JavaScript is a compiled language for all intents and purposes, unless you are running on a microcontroller or you are using one of the scripting host environments that you probably haven't heard of until just now.
So like, what is it, Esprino?
Yeah, so somebody just brought that up in the chat a little bit earlier because somebody was asking.
I have a couple of those things because I've seen like I think I have a watch that has JavaScript native on it. So I guess that might be a situation where it's what you're talking about.
Yeah, and a lot of those environments will not, we'll see, but it turns out it's really costly to run JavaScript in the ES 23000 because there's a lot of ambiguities in the language and they've introduced a lot of complexity, so it actually will have to do more of those things like the automatic semicolon insertion. It'll have to do that kind of stuff, for example, for arrow functions, because when you encounter an arrow function, how do you know if you're encountering an object or a block? If you're just looking at it as a human, you might think it's an object, but actually it's a block. A lot of the scripting host environments, well, most of them that have existed up until yesterday, they use ES3 or ES5 because ES5 is the smallest version of JavaScript that has the fewest rules, that has the least complexity, the least ambiguity. And if you're trying to run something on a microcontroller, you don't want the daggone interpreter to have to do a headache full of work to figure out what it's supposed to do. You want it to be able to execute efficiently.
You want the Wild West version, got it.
Well, no, you want the less Wild West version.
No.
So ES5...
There's less rules applied on top, so you want the more Wild West version that anything kind of goes.
No, ES5 has the least flexibility.
It has the least flexibility?
Yeah, so you can implement any JavaScript program in ES5 that any JavaScript you can run, but it has the fewest number of options.
So no let and const and stuff like that? So you mean?
Yeah, so you don't have let, you don't have const, you don't have arrow functions, you don't have classes, because all of these things are they're literally syntax sugar, right? That's why Babel works, because all you're doing is saying, oh, I want to do a find and replace through my code. Anywhere I find this, replace it with that. That's all you're doing is basically text editing. So in ES5, it doesn't have to do any of that extra work. on top. It can just go directly to, the JavaScript. The one exception to that is async await does actually get to skip a step, because the way that promises are implemented, they have some additional flexibility that async await does not. So the early versions of async await were just syntax sugar, but the latest versions of async await actually are essentially one function call less in terms of their cost. They have one less micro tick.
Okay.
But it all compiles to the same thing, right? You're compiling it to ES5.
If you are transpiling async await to ES5, I think it would be the same as promises, yes. But if you're using a modern JavaScript engine, then async await has a slight advantage over a promise in that there is slightly less machinery that it has to run through.
So the optimization that we were hoping to get in the lazy form just doesn't pay off, and we get weirdness instead. Now, an argument about that might be, well, suppose we call this function 1,000,000 times or a gazillion times. A gazillion if statements, that starts to add up to something. And you can go, yeah, maybe that's true. But if you think you're really going to call this a gazillion times, we shouldn't be optimizing the case where we're not going to call it at all. I thought I heard some applause there. Maybe not. No. Okay. Okay, here's another example. A fade function. This is something you might do in an AJAX application. I want to take some object, maybe a div or something, and have it fade from yellow to white. Maybe as an indication to the user that something changed and they should pay attention to it. So I've got my fade function. First thing I do is find a DOM element and create a variable called level, which I'll set initially to 1. Then I'll define a step function, and then I will call set timeout, passing that step function with a time, so it'll fire in a tenth of a second, and then it returns, done. That's the end of fade. Then suddenly, a tenth of a second later approximately, the step function executes. And it will first define a variable h and initialize it with level. What is level? Level is the variable of fade. It's not the value of fade when it was created. It is the current value. It is the current variable. It does the same thing with DOM. It gets access to the DOM variable and uses that to change the background color of that DOM node. It then looks at level, and if it's less than 15, which it will be at this point, it will add 1 to it. It's adding 1 to the level variable of the fade function that's already returned. And then it will call set timeout, and in a tenth of a second, we'll do this again, and we'll keep doing it until eventually we reach 15, and then we stop. Now, suppose we had 3 things on the page, and we wanted them all to fade simultaneously. So we call fade 1, 2, 3 with 3 different IDs at the same time. Are those 3 executions going to interfere with each other? No, not at all, because each invocation of fade has its own unique set of variables, its own DOM, its own level, creates its own step functions. They do not interfere with each other at all. So this works again because of closure. Because step is able to close over the DOM and level variables, it just works. Everybody still with me? Okay, one more example along these lines. I want to make a later method. It's like set timeout except more object-oriented. So I want it to be a method of all objects. So I can take for any object, call it later, give it the number of milliseconds in which to wait. It doesn't actually wait, it puts it on a timer queue, and eventually it'll get around to dispatching it. Give it the name of a method, or perhaps pass in a function which will be treated as a method, and any other parameters that that method would need. And on the next screen, I'll show you what it looks like. But again, I'll point out the problem with arguments. What I'm going to want to be able to say is arguments.slice of 2, so that I can take all of the parameters that were passed except for the first 2 and make a nice little array out of it. I can't do that in ES3. Instead, I have to write array.prototype.slice.apply arguments sub array sub 2, which is pretty nasty. So when you see that on the next screen, you'll know why that is. In ES5, you can do the simpler thing. So I'm going to add this to object.prototype. I could add it to any of the ancestors in my application. This is one place to put it. Object.prototype is a global object. And so all of the problems you have with global variables, you have with global prototypes as well. And so this is something you want to do really cautiously. You want to do it conditionally, just in case the language ever actually adds later as standard equipment, so that you're not going to be replacing.
Don't ever use prototypes or classes, but especially not prototypes. The end. No, and later on he says, in one of his later videos, he says, I used to say prototypes were really cool, and then I realized they're actually a really bad idea, and so I don't use them anymore. There's no reason that you do. They only make things complicated. You potentially conflict with other things. So there's a lot of things that have stupid names in JavaScript because some framework, MooTools, was so incredibly popular that instead of having the function be called leftpad, it's called startpad. Well, actually, I think the reason it's called startpad is because you could have strings that go left to right or right to left, and startpad is more appropriate. But so that example was, I was incorrect about that. But other similar things. There are things in JavaScript that have weird names. The reason they have weird names is because Google Analytics reported that 10% of all websites have MooTools on it, and therefore 10% of websites would break if we updated the language to include each function. So it has to be called for each or whatever it is. And I'm coming up with bad examples off the top of my head, but you'll see it when you see it and you think that's a weird thing to name it. Why'd they name it that? It sounds more Latin than English. That's why. But yeah, and if you just return an object from a function, you never need a prototype because you can just put whatever you need on the object, and you can set its default values like you would normally do in any constructor. Okay.
The official version with your version. Generally, you don't want to be doing this in applications, although it's sometimes a reasonable thing to be doing in Ajax libraries. So in this case, if we don't already have an object.prototype.later method, we're going to define one, and we're going to pass in the number of milliseconds on the method. Then we'll create an array of the additional arguments. We're binding that to this. It's doing the thing I showed you before because in the green function, we're going to want access to this, but this doesn't work. This is not captured in closure, but that is, and so that's how we get that into it. That will call set timeout, and will cause that function's method to get invoked at that time. One other thing I'm doing here is when later is finished, which happens immediately, it returns the value of that, which is also this. And the advantage of doing that is that it allows us to then cascade on that. So if I had several things that I wanted to happen later but at different times, I could say my object dot later 5 dot later 10 dot later 20 and so on. I can just cascade all these things one after another because each returns its own object, so we can then go right on and invoke the next one. There are a lot of Ajax libraries that.
So what he just said there actually turns out to be useful if you're in a browser, because if you want to do something that requires a timeout, there is a, I forget what it's called, but there's a minimum timeout time of 1 second if your tab is not active. So let's say that you were playing some music and you wanted the music's volume to fade towards the end of the song. What you actually have to do is towards the end of the song, you have to stack up all of the changes in volume sequentially, one right after the other, because the set timeout will have a minimum, it's clamping, it's called clamping. Or no, it's the opposite of clamping. But anyway, the set timeout has a minimum value of 1 second. And so you would have to do just like what he said, you'd have to stack them at least 1 second in advance, the whole duration, so that when the tab isn't active, the volume will fade properly. They may have fixed that specific use case with the volume, with the audio APIs since I had to do that, but that was a legit thing.
Carry this idea to excess, but it's a really nice pattern, and I think it works really nicely in this language. Another example, partial application. We're starting to get a little theoretical now. Partial application says I'll take a function and a parameter and return another function which doesn't execute that yet, but will when it's supplied with additional parameters. So let's start with the example first. I'm going to, using a function called curry, I'm going to pass it an add function, which takes 2 arguments and adds them together, and I'm going to pass it 1. And it will return a function which will add 1 to whatever gets passed to it. So I'm going to store it in an increment, because that's a good name for that. And then I can call it. So if I pass a 6 now to inc, I get 7. And this is called partial application. So the implementation of it is I'll first get an array of arguments except for the first one, because the first one is the function. I don't need that one. And in this case, I'm assuming I'm on ES5, so I'm not doing the awful array.prototype.apply trick. And then curry returns a function. And that function will apply the arguments to the function. One bit of weirdness that's left over from arguments not being a real array is that if I pass arguments as a parameter to concat, it doesn't recognize that it's an array and then take all of the members of it and concatenate them to the other thing. It will concatenate them as a single array, which in this case is not what we want. So we need to turn it into a real array so that concat will do the right thing to it, and we do that by calling it slice method. So ES5, it has the slice method, so slice returns an array, so that'll work. But we shouldn't have had to do that. There's still some things left to get fixed in future editions. Everybody still with me? Okay. Here's one other. Suppose we've got a process which cannot be resolved immediately. Maybe it's going to require a lot of computation. Maybe it has to go out to a worker pool and do something. Maybe it has to go back to the server and get some stuff. But we'd like to be able to return something immediately that we can start acting on, even though it's not going to be real for a while, and we don't know when that while is yet. So a service that's doing something like that could return something that's called a promise. And the promise is an object which allows us to call methods on the thing, and if we know what the thing is, then they'll immediately get executed. But if we don't know what the thing is yet, they'll get queued up. And will finally get executed when we know what the thing is. That turns out to be a really useful pattern for doing a lot of things, particularly when you're doing a lot of communications. Here we're going to implement a promise maker. And the promise maker will return a set of 5 functions: when, fail, fulfill, smash, and status. If we call and it doesn't care. You could pass any one or any fraction of these functions to someone else. So, for example, you might have a service, and I want to return something to you immediately. So I give you back an object containing a when and a fail method. You can then pass to when functions that you want called when the thing is fulfilled. And you can also pass functions to fail for the case where a failure comes back. And it'll just sit on all of those things until it knows what the disposition is. And then the creator of the service might hang on to the fulfill and smash methods. Fulfill, he'll call and pass a value in when he knows what the value finally is. And that's the thing that will get delivered to the functions. And
So just to clarify real quick, the way that this was actually standardized is then, catch, resolve, reject. So where it says when here, that's .then. .when is .then, .fail is .catch, fulfill is resolve, smash is reject. So just so it's not too confusing.
Is status a thing?
Status is actually not implemented. And at first, because I was rewatching this recently, or at least a part of this part, I was watching to try to help somebody understand what promises are. And I thought, oh, that's weird, they didn't implement status. But then I thought about it, I've never had a need for status. I don't think I've ever needed to know whether a promise is fulfilled or not. That's kind of antithetical to what a promise is, to want to know the status of it. I think there maybe are some edge cases to that, but essentially in the cases where you'd want to know what the status is, you think about what you would be doing. Maybe you'd say, oh, well, I want to check in 5 seconds if this still isn't fulfilled, then I want to reject it. You know, but that's what promise.race is for. So you can put your the thing you hope happens and your fallback, or you could implement that in your function. Your HTTP request has a timeout property, stuff like that.
Doesn't it have something that returns pending? I know I've seen promises that are pending, and so
yes,
in some sense,
the
there is some sort of
console will show you non-enumerable state.
Okay.
So the console will show you things that are inside of the closure of the promise that are not actually accessible in any way, shape, or form in JavaScript.
Interesting. I didn't realize that.
Yeah, the console has special access. So this is one of the things I was saying about let earlier. The console used to, to me, let was just completely stupid to use until about, I don't know, a couple months ago when it got to the point where, like I said, all the bugs were fixed. One of the bugs is that if you use let in the console, and this is still the case in Node 16, if you use let in the console, you cannot redeclare it. So if you're trying to quickly prototype some code, it does you no good to declare variable A, and you say, oh, I want to change this function a little bit, and copy and paste these 3 lines. Have a good one. Thanks. Copy and paste these 3 lines again, and now it says, oh, well, you can't do this because A is already declared. So that's another superpower the console has. The console treats let like var. Kind of, sometimes.
And if it turns out that it's going to be an error, at this point it's too late to throw an exception because that was a long time ago and the other guy is not in your call stack anymore. So instead you smash the promise, you break the promise, and that will cause all of his fail methods now to run. So the way these things work is they depend on the vouch and resolve methods, which are private to the promise maker. But which, again, it closes over, so it'll always have access to those functions and the state that they refer to. So let me show you implementations of vouch and resolve. First, we've got a few more variables. We've got status, which initially is unresolved and eventually could be fulfilled or failed. We've got the outcome, so when we know what the value is, we'll stick it in there. Then we've got the waiting list of functions that were registered with when, and we've got the dreading list for the functions that were registered with fail. Then vouch will take a deed and a function, and then it'll look at the status. And if the status is still unresolved, then it will put it onto one of those lists. And which list it'll put it on will depend on what the deed is. But if the current state of the promise matches the deed, then we can execute it immediately. Then the other piece of this is resolve. If the status is already been resolved, then we throw an error because we can only do it once. Otherwise, we'll go through and using one of the nice things in ES5 now, we've got a for each method. So we'll figure out which of those two arrays of functions we've got, and we'll say for each one of those functions, call this function. And this function will then go and call each of those and with the value. And we had to wrap it in a try-catch because if any of those functions should throw, we don't want that to interfere with the other functions getting a chance to run. Okay, everybody still with me? We'll look at one more. Sealers and unsealers. So sometimes we'd like to be able to pass secret information around through the application. So say that I give to you a secret envelope, and I tell you, give it to the cashier, and the cashier will take care of you. I want you to be able to take that envelope to the cashier and get reimbursed, and I'd like you to be able to give that envelope to someone else and allow them to be reimbursed. But I don't want you to be able to open it yourself, and I don't want you to be able to tamper with it, and I want the cashier to be able to verify that, in fact, it is the original untampered with thing. We can do that really easily in JavaScript, it turns out. Now, it sounds like something you'd need public key cryptography to do, but that doesn't really work inside of an application. But it turns out there's a much simpler solution. So the way it works is I've got a sealer maker, which will return a pair of functions, a sealer and unsealer, and they have to be used in the pairs. So I will keep the sealer, I will give the unsealer to the cashier, then I can call the sealer with the value that I want to give to you, and it will return to me a box, which I can then give to you. And the box is useless to you, except that if you can give it to someone who's got an unsealer, they can reclaim the original object. One thing that this function is a tiny bit harder to write than it should be, because in JavaScript, object keys have to be strings. They can't be objects. If they could be objects, this function would be totally trivial. As it is, it's just slightly trivial. So what I'll do is I will create the box, the secret container, which is just an empty object. It's really just a token. I'm not actually giving you a real box, but it acts like a box. And I'll store it in my boxes array. And right next to it, I will store in my values array the value that it represents, and then return the box to you. So that was really easy. And then the unsealer uses the new index of method that we have in arrays and goes looking for that box in the list of boxes. And if it finds it, then it returns the corresponding value, and we've got it. And if something goes wrong, if you pulled a substitution, gave an object that was not sealed, you get undefined back, which is how it should be. So we're going to shift slightly and start looking at inheritance, but we're
What is index of newer? Is that like an ES5 thing or something?
Index up? No, that's always been there. Index
That's what
up.
I thought. He said something like our new index of method. He said it right at the, like, in the last, I don't know, 30
Oh, okay.
seconds.
Maybe, I don't know, maybe it is. Maybe it was not there on, maybe it wasn't there on strings, but is it? I could be wrong.
It was the last slide he was showing, but, yeah, I don't know.
When would we use that?
Index up?
No, the
We're still-
sealer, unsealer.
Oh, the sealer, unsealer?
Yeah.
So the example that I would say would be, so most of the time when you're writing JavaScript, you're only thinking about your application. But when you visit a web page, there are several applications running. There's going to be an Auth0 application, there's going to be an ad network application, there's going to be a Facebook-like application. You know, so your page is going to have maybe 6 or 7 or 24 applications running on it for all of the social features and advertising features, et cetera, et cetera, et cetera. Even, you know, your Stripe, your Plaid, your, you know, all this stuff, and it's there all the time. And they're collecting analytics and they're doing all sorts of things that you don't think that they're doing, right? And then they get hacked. And then when they get hacked, well, now the hacker's code has been deployed across an entire network of applications. So the idea behind this, which I think is somewhat flawed in the sense that I don't think that you really can protect against these scenarios, because once an attacker has access to the page, they can manipulate it in such a way that they can get what they can get what they want out of it. But the idea here is that if you have some sort of object that you want to be able to have access to in any of your application components, but you don't want it to be available to something else that's running in the page, you can make it publicly available to any application on the page, but only your applications would be able to get the specific value out of it. And if you wanted to do this now, this is also, so symbols are basically syntax sugar for this. So in any case where you would use a symbol, which I think should be 0, I don't think that the average person has any use for that, and there may be some really weird niche case where somebody that's developing extremely low-level performance-sensitive frameworks or something might need a symbol, but you don't need symbols. You could just use this if you, for whatever reason, thought you needed a symbol. And then also, you see the same kind of thing with web crypto and with Node crypto, which I think they should have just done this instead of implementing new language features, because this solves that problem. But you have an opaque crypto object that only has the ability to do some operation, but you can't get access to whatever the keys are inside. You can build those types of things with this. So you can pass the object around, but only something that has the key can then use that object in whatever particular way.
Okay.
And if that didn't make sense, it's because you literally don't need this.
Yeah. Well, until you need it. Yes.
I don't think you do. There's a lot of things that you literally
I've never
need.
run it. I've never run into it. So.
Yeah, it's one of those things where if you take things to their logical conclusion, I think you'd find that you would literally never need this. Because the use cases where you think you would need it, there's something else going on in the way the application is working that either that functionality is already provided or it's not realistically possible, because if the attacker is able to get access to A, then the attacker also has access to B already in the first place. So.
Back, which is how it should be. So we're going to shift slightly and start looking at inheritance, but we're still going to reflect it back onto what we can do with closure. So here's an example of how you can do things with what I call pseudo-classical inheritance. This was the inheritance scheme that was designed for the language. And I really don't care for it at all. I don't think it looks very good. So here we're defining a gizmo, and you can see the gizmo's constructor. And then we add to the gizmo's prototype the methods that we want the instances to inherit. This just looks really weird. We're sort of used to the idea of a class kind of containing all of its stuff, and in this case it's kind of hanging on the end of it in sort of a haphazard way. It also induces people to do things incorrectly. For example, I've seen people trying to assign functions to prototypes inside of the constructor because it just seems like that's where you should do it. And doing it on the outside just feels wrong, even though that's how you're supposed to do it. It gets even worse in the case of the whosit, where I want the whosit to inherit from the gizmo. So the way I specify that in the language is I replace whosit's prototype with a new instance of gizmo. And that just looks crazy. And it's potentially dangerous. If it turns out that the gizmo constructor would throw if there were no parameters, then it would actually fail. But this is the way the language was intended to be used. And it's because the language itself is confused about its prototypal nature. So I think there's a better way to do this. So let me suggest another formulation of exactly these same objects. So here I'm going to make a gizmo, and to make it for me, I'm going to call my new constructor function, and it will make the new thing, the new instance of gizmo, or the new definer of gizmo. And I will pass to it object because I want gizmo to inherit from object, and I'm going to pass to it the constructor function, and I'm going to pass to it an object containing the methods that it should add to its own prototype. So this does exactly the same thing that we saw on the other screen. I think it's just more pleasant looking. And then it gets even better with the whosit. So the whosit I call new constructor, pass in the gizmo that says I want whosit to inherit from gizmo, and I also pass it a constructor, and I'll also pass it an object containing additional methods that I want it to add to its prototype. So, to my eye, this looks a whole lot more rational than that did, with all that stuff hanging out in the weird replacement. So the language doesn't provide the new constructor function that you need to do this, but it turns out it's a really easy function to write. So let's write that function. So function new constructor takes 3 parameters, extend, initializer, and methods. First thing it does is it creates the prototype object, which it makes by calling object.create. And then if there are methods available, it will call the keys method. This is a new thing in ES5. Call the keys method, which will return an array of all of the own keys of that object, which is really nice because an array has a for each method. So we'll then call that. So that will allow us to easily copy all of the methods into the prototype. Really nice construction. Then we'll create the function itself, which we'll use to make our whosits or whatever. And you can see that closure is working in there because it has access to prototype and it has access to the initializer. So it will create a new instance of the prototype using object.create, which makes a new object that inherits from the object that you pass in. And it will then call the initializer, passing that same object in. And when it's done, it will return the object that we just created. So this does the same thing as new, except we don't use new. And then a little bit of extra plumbing. We don't really need to do this, but just to be nice, we'll set the function's prototype property to the prototype. Because in the case of the whosit, the prototype got replaced, and so we lost the constructor value, and we'll fix that there as well. So again, we're using closure in order to implement a classical pattern, and I think this works really nicely in the language. Another thing we can do with functions is to create modules. We'd like to be able to avoid creating global variables, to minimize use of global variables because of the conflicts that they can create, and functions provide a very nice way of doing that. So here I want to create a singleton object. There'll just be one instance of it. So you don't want to have to create a class to define something that there's just going to be one instance of. That'd be silly. So I'm going to assign to singleton not that function, but the consequence of calling that function. And again, I'm wrapping the whole function and the invocation in parens as a sign to the reader that there's something bigger going on than just assignment of a function. There's some people who would put the golden paren around the function and not around the whole invocation. That doesn't make sense to me, because what we're trying to tell the user is, look at the whole thing. And putting parentheses around just part of it, I think, is counterproductive. So I think the whole thing needs to be wrapped in parens. So the outer function has variables and functions, and then we'll return an object using an object literal, and the object will contain some methods, and those methods will be closed over the private stuff. So we're returning, in this case, 2 functions. In the earlier cases, we returned 1 function. This time we're returning 2. We could return as many as we want, and they share their access. They're both closed over the variables of the parent function. So they can communicate through those, through that shared state without corrupting the global space. A related pattern to this is we want to have a common global object where we'll keep our whole application. At Yahoo, we keep a lot of stuff in a global Yahoo object, so that everything that's ours we keep in one common namespace. And so I want to add a new thing to my global object called methodical, which will have my 2 methods in it. So just as before, I'm going to be assigning the result of my function into that object. Now, sometimes I want to be adding not a new object to that structure, but just add a couple of methods to that structure. And I can do that as well. So here's another variation on the same pattern. I've got a function, and it's got the private stuff, and then I'm going to assign to global.first method my method, and to global.second method the other one. And again, the whole thing is wrapped in the golden parentheses. In this case, the parentheses are syntactically required. That's because I want this to be a function expression and not a function statement. If it were a function statement, I couldn't immediately execute it, and I want to immediately execute it. Everybody still with me? So I can take this module pattern and very easily turn it into a constructor pattern. It's the same basic idea. I'm just going to make lots of instances, not just one instance. So here's the recipe. Step 1, make an object. Using any of the techniques available in the language, I can use an object literal, I can use new, I can use object.create, I can call another of these power constructors and use the thing that it returns. Then step 2, I define some variables and functions, and these will be the private members of the object that I'm about to make. Step 3, I augment the object with privileged methods. A privileged method is a method which has access to that private state, that closes over the private state. And step 4, I return the object. So really simple recipe, but it's a little abstract. So let me turn into a template that's a little easier to follow. So step 1, this is going to be my new power constructor, and I'm going to create a variable called that, because I can't call it this because this is a reserved word. And I will initialize it somehow. Somehow I turn it into an object. Then step 2, I declare secrets, a secret variable, stuff that's going to be available to my privileged method. Step 3, I create my privileged methods and assign them to that. And step 4, I return that. So really simple. Here's Gizmo and Who's It again. This is how we would write it again in the classical style, pseudo-classical style. And it's just, it still bothers me how all the stuff's hanging out. And also, Gizmo's got a constructor and Who's It's got a constructor, and they both do the same thing. So even though one inherits from the other, we don't get the advantage of that code reuse. There's some redundant waste going on there. So I want to apply this functional system instead to doing this. So this is how I would write it. So I've got my gizmo. It returns an object literal, done. That was really easy. And then my whosit calls Gizmo to create an instance. It augments that, adding its test method, and returns that done. So it's really simple. But there's some other benefits that come from writing in this style. One is that we've got privacy, where right now the way it's written, the ID is a global property of the object. So anybody could go in and get the ID directly or modify it. Maybe I don't want them to be able to do that. Maybe the integrity of my object depends on nobody being able to mess with the ID. So writing this in the functional style, we can do that. And not only can we do that, the code gets simpler. So we just don't have an ID property in the object. We're referring now to the ID parameter. And because of closure, our toString method always has access to that parameter. So we just took the thises out and it's done. And we do a similar thing with whosit. So again, it just became simpler. There are other things we could do too. We could have a shared secret which we pass between all of the constructors, which could be used to simulate something like a package relationship where they all contain something that they know. You can get arbitrarily complicated with this stuff. You usually don't need to get anywhere this fancy, but it's nice knowing that you can if the need should ever arise. When I started working with this language, I spent a lot of time thinking about how to simulate.
So earlier when I was talking about the shared secret thing, I think I was actually referring to this. I got distracted right during that portion because I was trying to figure out how to report some content that was showing up on the Twitch page.
It's always Twitch. It is. I mean, I remember you're like, hey, Will, man the Discord, and I'd see stuff just flowing in from Twitch. I'm like, well, there's no way for me to delete that because I don't have a Twitch account.
Yeah.
It just sits there.
Yeah, there's an account that's supposedly a legit account. It's got 8.8 million followers or something that keeps on showing up in the recommended, and it's obviously softcore. So.
Oh, like when I asked you to change the ASMR thing?
Yeah, exactly. Exactly. So I tried to block that category and it still wouldn't work anyway.
Well, literally, you having the word relax in your titles caused ASMR stuff. And so I'm like, what am I seeing for recommended right now? Like, I don't watch this stuff. Like,
Yeah. So anyway, I'll have to go back and review the seal and unseal because that might have been something different that I was thinking it was.
I don't know how it would be used in JavaScript, and I'm weak enough in this, so I don't have a good example, but it reminded me of what you can do for like in the back end with like HashiCorp Vault, where you can say like Vault has a encryption key I know nothing about, and you have permission to encrypt things, and you have permission to decrypt things.
Okay,
and
so it was on point.
So you like run something through and be like, here's this opaque token that only someone who has permission to decrypt can do something with, or they've got the sealing and wrapping stuff, which is similar.
I think
Yeah. So
GitHub
this-
has
this-
something like that.
This is similar with the shared secret idea.
Okay,
All right.
glad you showed up.
Yeah.
Have a good night.
Thanks.
Did you learn something?
Yeah, I did.
Okay.
I have not worked very much in like some of the deeper stuff, and so this was great.
Yeah. This is one of his longest videos because it's got the most stuff in it. But a lot of the patterns that I use, because I ignore most of this because I think that a lot of it is interesting to know, but superfluous in terms of practical applications. But I think this pattern in particular that he was just showing, or just, where is it, right here, right there, right there. Anyway, that's one of the things that I use all the time. And if you go in the Discord, you can grab the playlist. And up to this point, the first two videos are just history of programming, and he's talking about how certain patterns evolved and basically how we got to JavaScript. And then this is, this is one that I've watched it. When I first discovered it, I watched it at least 3 times just back to back, trying to grok everything and get the download. So,
That's basically the Savvy SDK.
yeah.
How you encapsulate like orgs and stuff. on it.
Also, I found out how to JS dock that so that it works properly.
Nice.
Yeah.
What was your name again?
Tyson.
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 I'm like, it's not Travis. I
No,
know
no,
that.
no, you're good, you're good.
It's nice to meet you, Tyson.
Okay, good to meet you.
See you, man.
Well, we got a few minutes left, 10 minutes left.
Working with this language, I spent a lot of time thinking about how to simulate things that we did in the classical languages, like how do we get super functions. In the pseudo-classical model, there's no easy way to write super functions. In the
1.5 speed or 1.25? Is anyone against that?
Yeah, we could.
I'm not against it.
We
It's
could
fine.
do that.
I normally listen at like 2.5, so this has been very slow to me.
Yeah. No, I'm cool with doing that. It's just, it depends on the person's voice because they basically,
They turn into chipmunks.
well, what they do is they tune the algorithm for women because it's all this, you know, woman power, whatever. And so if you have a very feminine voice as a man, if you have a very soft, even voice, then it sounds great on YouTube. But if you have a voice, he's got a lot of quirks in his voice, so let's see what it sounds like.
Yeah.
The functional style is really easy. I just capture a super function from the thing that I'm inheriting from, keep that in the closure, and then I can call it anytime I want. It turns out, though, in my career with this language, I've never once written a super function. I just think about things in a different way, so that style of dependency, that kind of comes from, I just haven't found the need for it. So if you find yourself wanting to have super functions, you might step back and figure out, well, why do I think I need that? And maybe there's a simpler way to think about this. Here's another thing we can do. I want to have a memoizer, which will remove nested functions within function from, keep that in the closure, and then I can call it anytime I want. It turns out, though, in my career with this language, I've never once written a super function. I just think about things in a different way, so that style of dependency, that kind of comes from, I just haven't found the need for it. So if you find yourself wanting to have super functions, you might step back and figure out, well, why do I think I need that? And maybe there's a simpler way to think about this. Here's another thing we can do. I want to have a memoizer, which will remember the result of previous callings of a function, particularly of recursive functions, so that we can avoid doing some work. For example, factorial can be given a recursive definition in which it's the product of the value and of calling factorial on the value diminished by 1. And so if you're like computing a table of factorials, you can spend a lot of time going over the same ground over and over and over again. And this function will prevent that. So what I'm going to pass to the memoizer is an array containing some of the values that we're going to remember. So the results for factorial of 0 and factorial of 1 will be 1 and 1. So we'll pass that in to get it started. And then we'll also pass in a function which defines what a factorial step is. In this case, it's multiplying n times the recurrence minus 1. And so when we go up to the memoizer, it takes that memo array and it takes the formula that we just passed in, and it will create a recurrence function, which is the thing that we'll call for each iteration, which will first look to see if we already have the result that we need in the memo array, and if it does, then we're done. And if not, then we will call the formula passing in itself, its own recurrence function, so that it can do the next step. Where this is a big win is in computing Fibonacci, because Fibonacci recurses on 2 legs at the same time, so it gets explosive. If you do Fibonacci of 40, say, it's in the trillions of iterations. This gets it down into the tens. So even though the program looks a little bit more complicated, it's hugely more efficient. And again, this is happening because of closure, because the recur function closes over the memo array and over the formula that we're recurring on. One bit of warning about functions. Don't declare functions in a loop. Don't make functions in a loop. For 2 reasons. One is it can be wasteful, because a new function object is created for each iteration. And if that's just wasteful. So JavaScript compilers tend not to do any kind of loop invariant analysis. So anything that you're doing in a loop that doesn't change over each iteration, you probably want to move it out of the loop anyway, just to make it go a little faster. But the bigger reason is that it gets really confusing, because you think that you're closing over the current value of the loop variables, but you're actually closing over their final values or their current values. And that's almost always not what you want. So let me show you an example. A really common error. Say you've got an array of divs and you want to attach an event handler to each one. So you go through the array in a loop, and for each one you want to add an onClick handler which will display its ID number when it's clicked on. And what you find is that they all come up with the same number and it's the wrong number. And you wonder, how did that happen? And it's because it's closing, when you add the function to onClick, it's closing over div ID, which is constantly changing. And so by the time you finally get around to clicking on them, you're going to be getting the final value, which was the value that kicked you out of the loop. So the way you get around that is by creating a separate function, which you're going to use to assign the functions to the event handler. So here I have a function called makeHandler, which will take the div ID and returns the event handler function. Then within the loop, we call makeHandler and take its result and stuff it into onClick. By doing that, we avoided creating any functions inside of the loop. And that way we avoided the confusion that came from that problem with closure. Here I have two versions of the factorial function that do exactly the same thing. The only difference is one of them uses a variable and the other uses a parameter to represent result. Otherwise, exactly the same. Tennant wrote a book called The Principles of Programming Languages, in which he demonstrated the principle of correspondence, which was a correspondence between variables and parameters. And JavaScript demonstrates it really well. So this shows that you could imagine a subset of JavaScript which didn't have variables. Would that still be a useful language? It turns out yes, and this is the proof that anything you can write with variables, you can write without variables. You can use a function closure instead to do the same thing. We can take that thought experiment one crazy step off the edge farther. Suppose we had a language in which we didn't have variables and which we didn't have assignment and we didn't have named functions. Could we still do recursion? And it turns out you can. I'm not sure you'd want to, but you can. So here is the strangest artifact in computer science. It's called the Y Combinator. It's a function. It's a really complicated function, although it's not very big. It's incredibly nested functions within functions, calling themselves, passing themselves as parameters to themselves. So I call Y, passing in a factorial formula. It returns a function, and the function it returns is the recursive factorial function. This is really wild stuff. And if you can figure this out, you can call yourself a computer scientist, because this is the really good stuff. And you can express this stuff in JavaScript. I mean, JavaScript is right up there with Lisp and Scheme. It is a functional language. You can do this stuff. And while this may have little practical value, in terms of increasing your powers as a programmer, this is the stuff to be playing with. You can get really, really deep. I see a lot of people playing with their Ajax stuff and wanting to show off, look at all the stuff I can do, and sometimes doing things which are probably reckless and ultimately not very smart. If you want to show that you're really smart, you ought to be doing this stuff off to the side where you're not going to hurt anybody. So JavaScript has good parts. It has really good parts. And these, I think, are the best of the parts. And again, this comes as a big surprise, because when JavaScript was introduced, nobody expected there was anything good about it at all. And the stuff that is good about this language is in there intentionally, by design. It wasn't accidental. You don't get stuff this good by accident. This is an amazingly good language, and that's why Ajax happened. We'll be talking a lot more about Ajax next week. The reason I was able to discover that JavaScript had good parts was because I knew something about functions. And the place where I first learned about functions was in a little book called The Little Lisper, which I highly recommend to you. The current edition of it is called The Little Schemer. It was updated to be about Scheme. It's not really about Scheme. There isn't very much Scheme in the book. It's mostly about functions, and it's really, really good. And it turns out everything that's in the book can be written in JavaScript. Although Scheme and JavaScript couldn't be more different syntactically, at their roots they're surprisingly similar. And so there's a simple transformation from one language to the other, surprisingly simple. And if you go to this web page, it'll show you exactly what they are. And that'll give you enough to be able to read and write the examples in the book. Highly, highly recommend that you go out and get this book. It will change the way you think. And there are very few books that do that. This is one of those books. So next time we meet, the metamorphosis of Ajax. It'll be awful. So see you here. Thank you and good night.
I need to watch that a couple more times.
Oh yeah, at least twice. At least twice. And pause and use the text sniper feature to be able to copy the code. Or I think
Tonight, episode 4,
actually link to his slides.
the metamorphosis of Ajax.
Could you link
All the
that
world's
video?
opinion.
Or it's probably in the meetup, right?
Yeah, I put it in the chat, I put it in the meetup description, I put it all over the place.
His function thing reminded me. There's a C compiler that uses only move instructions. So when you disassemble it, it just moves. It's just.
I think one of the first conversations I had with you
What's that?
was about that. You were telling me about it. I'm like, I don't know, C.
So yeah. So it just.
Well, it's not C, it's assembly.
Yeah. So C creates assembly, and it's like
Oh, that's right.
usually you can look at it and go, okay, here's the start of a function because it modifies the stack, or it's saving the stack registers, then it's accessing them. That apparently the x86 instruction set is so flexible that it has different modes, so that literally every instruction is move here, this to this, move this to this, everything. So the call, like you can disassemble a program and have a call graph, like okay, this stuff goes over here, and the call graph just looks like this. It's just ridiculous. So that's what that function there reminded me of. I was like, oh well, what if you only use one instruction to get it done?
I've got a hammer. Everything's a nail. Everything's a move.
Well, so there's a difference though, right?
Yeah.
Because there's a difference between saying, okay, to be cute, I'm gonna see if I can do this obscure thing that's harmful and make it work, versus I'm going to ignore everything that's harmful and only use the good parts.
Mm.
And that's where, the Crockford stuff I think is really good, because his philosophy is, hey, why don't we not do dumb, even if it looks cool, but do smart instead? And it turns out that doing smart instead requires fewer brain cells, because you only have to focus on the things that are easy and simple rather than focusing on the things that are complex.
Mm.
I mean, granted, he showed a lot of things in here that are fairly complex, but like he said, and even earlier, I said, oh, I can't believe he's showing this, and then the first thing he said is, don't do this, right? So he's showing, here's all the dumb things you can do, here's smart things you can do and dumb things you can do, and here's how to distinguish between smart and dumb. And that's kind of what this talk is.
I mean, at least in my experience, you have to know the dumb to know that it's dumb. So it's tempting to only teach the smart thing, but if you don't know what is dumb and why it's dumb, you're gonna make that mistake at some point without realizing why.
Well, I disagree. Because I think that a lot of the stuff that's dumb is stuff that's clever. And so you'd have to, the rule I have in the office, and Will can attest to this, is anytime I hear somebody say, that's cool, I turn around and immediately stop whatever they're doing.
I've said that a couple times. I've commented on Prex code. I was like, oh, that looks cool. And you're like, no, it's not.
Like,
because
cool AJ, so wait.
Yeah.
It means a completely different thing. The word cool has worked over the years.
It's ironically cool.
Cool was initially, back before I was jaded and an old grumpy man, cool was as in chill.
Mhm.
Because if you remember back in the 90s, there was a period of time where cool meant that you were even, steady,
Mhm.
that kind of thing.
Yeah.
So
Cool
that's,
Hand Luke.
What we got here
That wasn't even 90s.
Yeah.
I don't
is
know.
that
a
was what,
failure to
70s?
communicate.
You don't know Cool Hand Luke?
No, I don't.
What we
Okay.
got
Well,
here,
Yeah.
there's a failure to communicate. My grandpa said that all the time. I have no idea what Cool Hand Luke is.
But when
Really?
people talk about
I know it's a
code,
movie, right?
Paul Newman.
He just said that
guy
all the
who
time. He was
voiced
like, oh,
the
Cool Hand
sheriff
Luke
in
says.
Cars. Paul Newman was Cool Hand Luke, and he is in a prison, and he just he goes with the flow kind of, and things don't exactly go his way, but he's just cool about it. I don't know.
yeah, so that was from that period of time. But when people say that's cool in reference to code, what they mean is, I don't understand this. It's not intuitive. I wouldn't have ever thought to do it this way unless I'd seen someone else do it. And the reason I want to repeat it is because I want other people not to be able to understand what I'm doing, so that they think that what I'm doing is not immediately understandable and somehow unique and valuable, or valuable through uniqueness and
Yeah.
vanity.
I'm
I
gonna
think
try to
this whole
find
thing
that.
is cool.
I'm trying to find what I said.
Anyway. So, yeah, don't do cool stuff.
I'm gonna try to find it.
I think that might be the argument for teaching the things you shouldn't do, because if you teach just the right way, then people go into the wild, they see code, and they're like, oh, that's neat, and they don't understand it's an anti-pattern that they're doing something
Well,
else.
that's fair. That's fair. It's just if you want to be productive, it's just, I've said this a million times, but Apple has proven, if nothing else, that the reduced instruction set computer is the superior computer. And if you organize around needing to know fewer things, you can be more efficient. A CPU that does more is not a better CPU, it's a worse CPU.
I don't, so, I, you need to be able to recognize patterns, even if you do not understand the full scope of how to implement that pattern. Like, that's where I think you still need to know some of what's done so that
Yes.
you don't go down that route too far.
Agreed.
And that's where I think of it a lot like pathways. Like, this is a good road that has very few potholes, and it might not be glamorous, but you probably won't have any regrets. This road, if you go down, there's all the cool people and the cool kids, but they're gonna end up dead on drugs and jumping off cliffs and stuff. So, which road do you like? You have to be able to recognize that, yes, there's some bad stuff here, but if you can't recognize the bad stuff on that road, you might go down it too far.
Right.
And it might be too late before you realize you went down the wrong path.
Right.
Well, that's where I think teaching some of the bad is good.
So yes, I agree with that. I do agree with that. It's just, I think, it gets confusing. So for example, if you're trying to teach somebody right and left, just don't teach them at the same time. Just teach a kid right over and over and over again. This is my right hand. This is my right hand. My right hand, right leg. Because when you introduce two concepts at the same time, a lot of times it gets confusing which one was which. Maybe that doesn't quite apply in the scenario we're talking about. But
So I put in a PR to add a badge to our repository. You added, oh no, badges, that's never good. Remember the motto, if it sounds cool, do not do it.
yeah. Yeah.
You get a little badge though.
Yeah. Well, so think of it this way too. Houses are designed to look good from the outside. If you have a square house where you can fit everything neatly and perfectly, it looks really boring. You know, if you you don't find too many square houses, but go into a neighborhood where the houses are both large and square. If it's a two-story house, you almost never find a two-story house that's rectangular in shape. They always have jutty edges and everything. It's because we need noise in order to, I don't know, our brains just can't cope with simplicity very well.
No, I hate I live in a shoebox house, but I hate shoebox houses where it's literally a shoebox with the lid, basically. Like,
Nobody.
I hate how it looks, yeah.
But think how easy it is to run the HVAC in that, you know, to run the piping, to calculate the cost, to have it have structural integrity. You know, so the shoebox house is much more ideal from a functional perspective, but so much of the house is supposed to be aesthetic, right? But this is where, you know, my thing on code is, the purpose of code is not to be aesthetic. The purpose of code is to be purely functional. You want to very easily understand it. But people just have a hard time with that, because if it's easy to understand and it doesn't provide excitement, it's like, wow, this is really boring. Awesome! Good code should be really, really boring. We don't like boring things, and most people don't have the discipline to write boring code.
All right, Will. So do not say this is cool. Say this is awesome. That was my takeaway.
This is clear and functional.
Yeah. This is
AJ, this is awesome. We should implement it.
We'll see. We'll see how much all there is. All right, well, I think I'll go ahead and kick us off the stream here, and I need to get back home. So anybody who's still watching in, thanks for watching in. We'll catch you later. And like, sub, follow, etc. Discord, all the things. Adios.